Thank you. Hey, Reese. We're starting 6-8 notes, and we're just got through 6-7. We were kind of refreshing our brains that a common log is a log with base of 10, or sometimes you'll see it with just log x, and that has a base of 10. So if it doesn't have a number, you assume it's a base of 10. Ready for the most important thing I'm going to tell you today? And this is the most important thing you have to remember. Are you ready? Are your brains comprehending? Everybody listen. This is the most important thing I'm going to tell you today. A natural log is a log that has a base of e. So natural log is a log base e. Okay? We don't ever write him as a log base e, and I'm going to tell you how we're going to write him here in a second. But let's talk about what e means. E is a number. Even though it looks like a letter, it is actually a number. It's kind of like pi. E is a number that is a decimal number that never stops and never repeats. It's 2.7182818, blah, 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 and it goes on forever, right? And it never stops, okay? Kind of like pi, 3.14159, blah, 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 on forever, right? I don't know any more than that. E is that number, 2.7182818, blah, 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 it goes on forever. And this is a number that naturally occurs in compounding interest, okay? So like if you would put your, INTREST, if you put money into a bank, it's going to compound its interest, and it's going to compound kind of at a rate that relates to 2.7182818, blah, 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 all that good stuff, okay? That's going to be the naturally occurring number for compound interest. Kind of like pi is a naturally occurring number when we're dealing with circumference and area of circles. It's just a number that shows up in interest rates a lot, okay? So it does, the decimal number does go on forever, and it never repeats. No, it does go on forever. Yes, correct.
Basically
Pi.
No. It's like people think it's a thing.
Possibly.
I know.
Like the square root of 2 is another one that never stops or never
No,
repeats.
it's like the idea. And like people say it's a thing. But
Oh.
a lot of people don't believe it's a thing. It's not a thing.
I don't know.
I don't know.
Yeah. I don't know. All right, so log base e, that's the very most important thing I'm going to tell you today, and that is a natural log, but we never write it as log base e. Here's how we will write it. Are you absorbing? This is the second most important thing I'm going to tell you today, which is log base e is ln of x. We will never write it as log base e. We will only write it as ln, because ln is natural log. It is log natural. That's why it is ln, natural, log natural, or natural log. Ln is log base e. So anytime you see ln in the thing, you think log base e, and anytime you see log base e, you think ln, because they are interchangeable. They mean exactly the same thing. On your calculator, you will not have a log base e button. You will only have an ln button. Locate it now. Go. ln. What? What? You have an ln button, so it's easier just to type in and hit ln than it is log base e, right? Even though you can make it log base e, you might as well just use ln because it's one key. Okay? What? Why?
Isaac, what time's your game? 2:30. What time? 2:30.
Okay.
Why did you ask? Because I asked Josie and
Okay.
he said 7:30.
Sure.
7:30.
I missed the game.
Okay. All right. So log base e and ln are the same thing. Let's go into a problem. Ready? Go down to example 1. Go to example 1. Okay. A and B are exponential functions. I know that because I have exponents here. These are both exponential functions. Do you see e to the x and e to the 5th power? Those are exponentials. I want to make them into a log function, right? So I'm going to start with this guy, and I'm going to make him into a log function, just like we've done before. We start with the log, and what's the base of that log going to be if I do my switcheroo? Log base e of 8 equals x, right? Log base e of 8 equals x. Now, we won't finish writing him like that because log base e is the same as ln. So we write him more properly as ln of x. And that is how we do our switcheroo, right? It's the same as what we're doing before, but we're just renaming him as ln rather than calling him log base e. Same thing, okay? Let's go over to part B, same principle. This is an exponential function. We want to write him as a log, so we start with log base e again of x equals 5, but we don't leave it like that because log base e is the same thing as ln. So ln of x equals 5, and that's how we properly write him. Okay? Not yet. We will here in a minute. Okay, in the next example. Not the next example, the example after that. Okay, so we're just right now doing the switcheroo from log to exponential like we've been doing before. Okay, ln x equals 5. That's exactly right.
The last one be ln x equals 8.
What?
The last one, ln x equals 8.
Ln 8 equals x. Okay, all right, this one, example 2, this is a log function. And we want to do the switcheroo and make him into an exponential function. But the first thing that we have to do is ln is equivalent to log base e, right? Now let's do our switcheroo. So log base e of x equals that. That means my base is e to the 0.7741, and that's equal to x. We're just doing our little switcheroo from log to exponential, just like we've done before so many times, right? Yep. B, ln, before we do our switcheroo, is log base e, and now we want to make it an exponential function. Okay, so he looks like e to the x equals 10. We're just doing our switcheroo. They're just one extra step.
Wait. Why did you cross out ln? I thought we wanted the ln.
What?
Because he switched it to
Because when we switch it to an exponential function, we have to change them to log base e. If we're switching from e's to logs, we want our final step to be an ln. But going backwards, we have to switch it to log e to come back the other direction, right? Okay?
No, we're just flipping.
Right. Yes. So the last two examples, like this process right here is the opposite of this process right here. Like you're just going from one to the other and vice versa. Okay, so those two examples are very similar. Okay? Example 3, now we're going to be putting stuff together. Woo! Okay, all right, I'll wait a second. Yeah. Yep. Okay. So when you're doing this, though, pay attention to instructions very carefully, because in these next two, A and B, we are not actually solving anything. It says write it as a single log, right? So we're just gonna get it down to one piece, and by doing that, I have two pieces here, but minuses between them, so we're gonna eventually have to divide, right? Like we've done before. Okay. Before I can put those together with division, though, I have to do one thing. Move the 3 to the back. Where does he go to the back of? The 10. And 10 to the third power is 1,000. Oop, ln, not log. Ln of 1,000, right? That's 10 to the third power minus ln of 8. And now they want us to combine them. But minus means divide, yeah? Okay? So we're going to divide ln of, what are we dividing? 1,000 divided by 8. And when we do that, what's 1,000 divided by 8? 125. There we go. Okay. Some people like to do this. Some people like to write your answer as ln with parentheses of 125, because on your calculator it opens up parentheses. But both of these things mean the same thing. Do you understand that? Your ln of 125 with or without parentheses, those mean the same thing. Okay. Over here on this one, now we have 3 pieces to put together, right? Okay. So, can I zoom in?
Yeah.
Okay, so over here we have 3 pieces, 1, 2, 3, but before we try to put anything together, we have to move some stuff. Well, one thing. The 2 goes to the back of the 1/2, okay? And that's not 1/2 times 2, that's 1/2 squared. What's 1/2 squared? 1/4, okay? So that's what he looks like. I'm just going to carry everything else down and rewrite the problem, okay? ln 40. Caitlin, are you writing this down? Okay. So 1/4 is that middle piece, and now we're going to put stuff together. If you have to, and you cannot put all 3 of them together at the same time, you can do just 2 pieces at a time, okay? So let's just worry about putting those 2 together. Plus means multiply, right? So we just put those together. 40 times 1/4 is 10. So that's ln 10, and then I'm going to carry this guy down plus ln x, okay? So if you want to put them all together at the same time, you sure can do that. I don't care. But now I'm going to put these 2 together. If you have to do it in pieces, you sure can. Plus means multiply. 10 times x is 10x, okay? Now, I don't care if you write that with parentheses or without parentheses, but know that this means the same thing. It doesn't matter how you write it. Some people like the parentheses. I kind of like the parentheses, actually. So whatever. It's fine. Okay, good. Let's start actually solving something. So let's go to the backside here, okay? And there are two different ways that I'm going to solve this for you. I'm going to show you how to solve. You choose whichever option makes the most sense to you, okay? So, option number 1. Here's my equal sign, okay? Option number 1. All right, I'm going to show you how to solve this 2 different ways. I'm going to do option number 2 over here, and you tell me which one makes the most sense to you. All right, number 1, we're going to solve that thing, and there's first some things that we have to do before we can even, like, do the weird things. Let's add the 5 over, right? Let's deal with the numbers first. So if I add the 5 over, 4e to the negative 2x equals 8. Now what? Divide what? The 4. Yeah, let's divide by 4. Let's get the 4 out of the way, right? And we're solving for x in the exponent, right? But the only way of getting that down out of the exponent is by having a log, right? We know that, right? We have to get them down out of the front. But in the last section, what we would do is we would do log in front. This time we're going to do ln because 10 to the x power, the inverse of him is log base 10. E to the x power, his inverse is ln, right? Log base e, right? So rather than using log in front of both sides, we're going to do ln in front of both sides, okay? And let me show you how the magic works. Ready? If I ln both sides, here's how this works. ln and e cancel out with each other. So on the left side, all I have is negative 2x equals ln of 2. You see how that works? ln and e cancel each other out, and the negative 2x comes down in front, right? But ln and e cancel out, so negative 2x is all that I have on the left side. And then all I'm going to do is divide by negative 2. So x divided negative 2 divided negative 2, x equals, and you're going to do ln of 2 divided by negative 2. Yes. Yes. So we ln'd both sides. You see that? Yeah. Like we would log both sides. But it just so happens that when we ln the e and the ln cross out. What did you get?
Where's Bojo at?
What are you talking about? Oh, and they, I don't know. Okay,
You need-
ELN, you don't want ELN. You want LN
Honestly, I like
Two.
these calculators better.
Enter.
than
divided by negative.
Negative.
Negative 0 point.
Just because like
3, 4, 6, 6.
Negative 0.3466.
these ones have more like.
Okay. All right, that's one way. So you're putting ln in front of both sides. So strategy over here. ln to both sides. ln to both sides. That's that strategy over there. All right, I'm going to solve this a different way. And you can decide. I like to give you options so you can decide. I'm going to rewrite this function and I'm going to solve it a different way. And we're going to see if we get the same answer. Which we will if we do it right. Okay. Same first steps. You're going to add the 5 over, right? Plus 5 plus 5. 4e to the negative 2x equals 8. Divide by 4. E to the negative 2x equals 2. Okay? And at this step, what did we do on the other side at this step? We ln'd both sides, right? We logged both sides, okay? In this one, the strategy that we're going to use is we're going to take this e and we're going to make it into a log, right? Okay? So if I make it into a log, just like we did in the first couple examples, this will be log base e of what? 2 equals negative 2x, right? But what is log base e? ln. So this literally says ln2 equals negative 2x. Oh, wait a minute, though. Look at where we had that over here. ln of 2 equals negative 2x, right? So it's the same thing. We're going to divide by negative 2. Divide negative 2, and we should get negative 0.3, whatever it was, 466. Okay? So the strategy over here was make a log e function, which is really like ln, right? So rather than ln'ing both sides like what we did in the last section, we're going to make it into a log base e function. Whichever way you would like to do it, it doesn't matter. Whichever way makes most sense to you. but you're going to get the same answer. You have options. That's why I like logs. You have so many options of what you can do. It's very nice. Okay? Good? All right, now let's solve some more stuff. Example 5. Are we ready? Are we good? Good to go? Okay, here is my equal sign. And let's do some things. What would you like to do? I don't want to do that. You could. You can move the 3 behind, but then you have to cube the 4 and cube the x, and I don't want to do that. Let's divide the 3 over, because 24 divides by 3 nicely, doesn't it? We have ln of 4x equals 8. Okay, now what? Well, we can't divide the 4. The 4 is stuck inside of the ln. The 4 is stuck inside of the ln. No, it's already a log. ln is a log. ln is Josie. ln is log e, right? So now let's e it. Let's make it into an exponential function where we change it to e to the what?
Wait, so we log e? E to the 8th power equals 4.
Equals 4x, right? We're making it into an exponential function. So it's a log right now. We're making it into an exponential function, all right? E to the 8th power is a huge number, whatever, but after we do e to the 8th power in our calculator, we're going to divide it by 4. So e to the 8th power divided by 4.
745.
Yep. Perfect. 745.2395. Huge number, because e to the 8th power is going to be a really big number, right? You're taking it times itself 8 times. That's going to be a big number. Divided by 4 is still really big. So, okay? Good? Happy with that? Yeah, not too bad. We can do that. Okay? All right, sure. Okay, B. Now, it doesn't matter that that's not an equal sign. We'll just leave it alone, okay? We can't distribute the 4 because this would end up being like x minus 8 times x minus 8, and I don't want to FOIL it 4 times. I don't want to do that. What? I don't want to do that. Ah, okay, that's a good idea. Let's move the 4. I hate exponents. We move the 4 to the front, so 4 is here, right? Then divide by the 4, so we get him to the other side. So we just have ln of x minus 8 is less than 1. That looks a lot nicer. No exponents. We hate exponents.
Wait, but how does the just the equal sign stay when we switch to
Nope, it just stays in the same spot. Yeah. Yeah, it just stays facing the same direction. So ln is log base e, right? Okay? And log base e, if we switch that to an exponential function, is e to the first power is less than x minus 8. Okay? It just stays in the same spot when you move it to the exponential function. Okay? And then you add the 8 over to the other side, so plus 8. Okay? So on your calculator, to get a decimal, do e to the first power plus 8. And you've still got x on the right side. Same symbol. What's this number? 8.3. Okay. If you need to, you can switch it back around. If you like the x to be on the left side, it doesn't matter. 183.
I like my x on the left side.
It doesn't. You like your x on the right side? You go for it. Okay. Good? Happy with that?
Oh, yeah.
Yes, right? Because we moved it to the front and then we divided it over. Very nice, yes. Okay? All right, I love these. I know that you hate story problems, but I like these. These are very satisfying because they give purpose to what we're doing here, right? Like they give me like a reason why we need to know this, okay? But first, we are going to look at this box, and this equation right here, my trig kids are doing right now. They just took a test over this. We call this equation PERT. Do you see the word PERT? P-E-R-T. That is a word, that's what we call it. This is the equation that we use for continuous compound interest. This is how interest compounds continuously in like a bank account. Okay, continuous compound interest. And we used some of these variables before, like A. What does A stand for? I call it the after amount because after starts with A, or like it's the ending amount. What's P? Why do they use a P?
period of time?
P is principal, and principal means where you start, right? The principal is where you start, okay? What does E stand for? Just a number, right? E is just a number. Get that in your head so that you know that E is just a number. R is the rate. Woo. Sign into Messenger. No, thank you. And t is time, just like always. So we're going to use this equation down below to solve some of these things. And we have a story problem. Ready? Here we go. When Angelina was born, her grandparents are wonderful people. They deposited $3,000 into her college savings account. Okay, what's $3,000? P. P is 3,000. Right, nowadays. But you just wait, it's going to grow a lot. Okay?
Yeah, 4% interest is
All right. Paying 4% interest.
pretty much involved.
Isn't that rate?
4% is rate. Yep. Compounded continuously, so we know we're using that PERT equation. And in part A, they're saying assuming that there are no deposits or withdrawals, meaning we're just putting the 3,000 in there and letting it sit. So we're not adding to it, we're not taking away. What will the balance be after 10 years? What's 10? T. Okay, so what are we solving for in the PERT equation thing?
A.
We're solving for after, right? A. Okay, P is 3,000, so we're just plugging stuff in. Times, E to the, what's R?
0.44.
0.04, right? As a decimal, 4% would be 0.04 times T, which is 10. Okay? Now, you should be able to type that whole thing into your calculator. 3,000 E to the 0.04 times 10. That good stuff. It should be something like 4,400 something. I don't know. Okay, hold on. 4,475 point. We'll go 48 because we're just doing change, right? So, like that. Okay, let me see which type.
It's 0.47 because it's
'Yeah, that one extra penny is just gonna change.
It should be 47.
No, it's way too rich.
What did I do wrong with this?
Your calculator is whacking. Yeah, that's fine. Okay, so there's that. Yes, happy with that? All right, B is going to be where the hard part comes in. So really listen to this one because this is why we're doing what we're doing, okay? How long? This is the first word. That tells me exactly what I need to know. We're solving for how long, which is T. That's what we don't know. How long means solving for T, okay? Will it take the balance to reach at least 10,000? So what's 10,000 going to be? A. All right, so 10,000 is my after amount. I'm still starting with 3,000. E to the 0.04, but this time I don't know what T is, so I'm going to put T there. Okay, now, I want it to be at least. So that doesn't mean equals, that means at least, right? At least.
31.
That means this has to be bigger than this, right? So I'm going to use this symbol because I want that to be bigger than 10,000, yeah? What? It can be equal to, so I'm going to do less than or equal to. No, because you're not going to get the right answer. You're not going to get you might get close to the right answer, but we're going to get the exact answer. We're going to get exact. Yep. Okay, so we're going to solve this thing. Think about the same problem that we did on your, number 16 on the homework that we just turned in. The first thing we did was divide that beginning number off, right? Divide that by that beginning number, 3,000. Okay, knock the zeros off. 10 divided by 3 is 3 1/3, and I don't like to make it into a decimal because if it's 0.3 repeating, and if we just write 0.3, that's rounded. So I'm going to leave it as 10 over 3 for right now. Okay, just chill with me. E to the 0.04 T. All right, we're solving for what? We're solving for T, right? How do I get that T down out of there? How does he come down? The only way of making him come down is by putting a log there, right? Right? Or switching around and making a log function. So we're going to do ln to both sides, right? And that makes the ln and e cancel out. Do we see how this works? Yeah? So ln of 10 over 3, I'm inserting the parentheses in there just because, is less than or equal to, what's on the right side? 0.04 T, right? He comes down when you have the ln there, and the ln and e cancel out, okay? Now, all I have to do to solve for T is divide by 0.04. So do ln of 10 over 3 first, and then divide by 0.04. And T has to be greater than or equal to, it's 30.1 years, I think. Check and make sure that that is right. What?
Oh, well, I had that, but.
I think so.
that button's
Yep,
like
yep,
a little-
yep. That means your fraction. Okay. So what does that mean? How long does that money got to sit there?
30 years.
Like a little bit over 30 years. Okay. But problem, is she going to go to college at 30 years?
Probably younger.
Probably like 18 years. So that's part C. If her grandparents want Angelina to have that $10,000 after 18 years, they're going to have to invest more than $300 or $3,000 to start with, right?
Yeah.
They want to know how much they need to invest to start with. So what are we solving for? P. We don't know what we have, right? We don't know what we're putting in to start with. But we know that it has to be 10,000. And P is what we're solving for. E to the, our interest rate is still 0.04. But this time we're taking it times 18. Okay, now, this one's easier than part B. Part B was the hardest part. C is easier because what we're solving for is not in the exponent. So we don't have to use a log to get him down, right? Okay, so what we're going to do is this right here, e to the 0.04 times 18. We can do that in our calculator. Figure out what that number is. It's like 2 point something.
2.0544.
Okay, something like that. And we got 10,000 on this side. Now what? Divide by the 2.0544, right? Okay, and then we've got P equals. And it's like 4,000.
It's 4,867.6.
0.60.
Yeah, 0.652.
Oh, did you divide by the 2.0544 or did you divide by the actual decimal number? So you took 10,000 divided by this. So then yours is more accurate. Because you
I
retyped
didn't do
the...
it by the exact thing. I did
Yes,
it by
okay.
the-
So it's going to be close. Because we rounded this off to 4 decimal places and then we're retyping that number, it's not going to be as accurate as actually doing 10,000 divided by E, whatever. So yours is going to be the more accurate one. Let's do that one. What did you get? 0.5. Is it 67.52?
Yeah.
Yeah, there we go. So we have to invest almost $5,000. Okay, a lot different than the $3,000 that we had, right? $5,000 now, almost $4,800 is what we have to invest if we want it to become 10,000 in 18 years. The change, 0.52. You know, like you write. Have you guys filled out checks before? You write the money and the right. So like if you have, I don't know, $24 and you're writing a check, you put it in the box and you write 20. You don't write $24 like that, right? Don't you put the change up higher?
No, you put it over and over. You would put like 52 over 100.
And that's when you're filling it out over here. So like when you're writing out, this would be like, I can't write with this pen. 24
Oh yeah, then you put like.
and 00 over 100, and then you go all the way across. Yeah. No.
So they can't add to it.
Right. I know. You get like checks are almost obsolete
I
anymore.
haven't got a check since I first started it all.
So there you go. Yeah. There you go. Okay, happy with that? Okay, do you guys have homework assignment yet? No, I have it right here. I'll give it to you. Okay, if you're watching this video, the homework assignment 1 through 6, we're going to do all of them because those are just the switching around. And then after that, on this side, you're only doing the odds all the way down, and you're only doing the odds on this side. So it's odds on everything except 1 through 6 is all, okay? So going all the way down, we're doing odds on this page. This is the only one that you have to do all because it's just the switcheroos, okay? Goodbye, people in the video.